Good morning, students. Up to the last lecture, we just introduced the concept of valency. Okay. Now, today we have to see detail the concept of valency. Okay. So, up to now, we are studied that structure of atom. In the structure of atom, at the center, at the middle of atom, one nucleus is there. Okay. And around that nucleus, what electrons are revolved in particular shells. Okay. Also, we studied the maximum capacity of shell. How much maximum number of electron can be stay in particular shell. We see first shell is K. In maximum capacity of K shell is 2. Okay. Then we study second L shell. Okay. We see that in L shell maximum capacity of electron is 8. Okay. Then M shell. There we see 18 electron can be maximum electrons are there in the M shell. Next N shell. Okay. There we see 32 maximum electron will be stay in the which shell? N shell. Okay, so this is the maximum capacity of shells. Okay, that much maximum number of electrons can be stay in K shell. We see in K shell maximum 2 electrons are there. 3 electrons we never find in K shell. Okay, then L shell 8 electrons. If you study the electronic configuration at that time, okay, L shell 8 electron, M shell 18, N shell 32. Okay, so such a way electrons are arranged in an atom in this manner. Okay, now there are also we study one concept, that is the valence electron. So there are, I draw a one diagram. This is the nucleus. Okay, this is the first shell, that is the K shell. This is the second shell, this is the M shell. Okay, so this is the outermost shell of this atom. Okay, so look at, suppose this is a oxygen or a carbon atom. Okay, so 6 electron in the carbon atom, so 2 electrons in first K shell, then remaining 4 in second L shell. Okay, so look at, this is the outermost shell. Okay, is also called, I said, valence shell. Okay, this is the outermost shell of atom, is also called valence shell. Okay, and the electrons which are present in this valence shell. Okay, look at, this is the outermost shell. In that outermost shell, whatever the electrons are present, that electrons are also called valence electrons. Okay, valence electrons. So these valence electrons are important us to study the valency of any element. Okay, this valence electron concept is important to us. Okay, so valence electrons are nothing but only the electrons which are present in the outermost shell of an atom. That electrons are called valence electrons. Okay, so now look at, we have to study the atomic structure of helium and neon gases. Okay, we know helium has 2 electrons. Helium has 2 electrons and neon has 10 electrons. Okay, we have to see how the electrons are arranged in these 2 atoms. Okay, look at helium 2. First we draw atomic structure of helium. Okay, so look at, this is the nucleus and this is the first shell of this helium atom. Okay, this is the nucleus, this is the K shell. Okay, so look at here now, it has only 2 electrons. So look at here. Okay, so in the helium atom, what happened? Only one shell is there, and that is the K shell. Okay, we know maximum capacity of K cell is how much? two electrons. So look at this helium, two electrons are there. Okay, so we can say that what this shell is completely filled because its maximum capacity is 2 and 2 electrons are present in the outermost shell. Now for helium atom, K shell is the outermost shell, first shell is the outermost shell. So this first shell is full filled. Okay, means what? Not less electrons are present less than 2 or not more than 2 electrons are there, means next shell is also not there. So first shell is full filled. Okay, so also one example we have to see, that is the neon. Okay, it has 10 electrons. This is the nucleus, this is the first shell, K shell. So in K shell we know there are only maximum 2 electrons can be stay there. Okay, then remaining electrons are go to the next stage. Okay, so if you write here electronic configuration, then that will be as like this 2 8. Okay, so remaining 8 electrons are will be in next stage. Okay, so look at here, in first K shell there are only 2 electrons and remaining 8 electron goes to the next energy stage, that is the shell. Okay, so look at again, maximum capacity of L shell is how much? 8. Okay, what maximum capacity of L shell is how much? 8. So look at here, in L shell again 1 2 3 4 5 6 7 8 electrons are there, means here outermost orbit is which? L orbit. Okay, L orbit is outermost orbit and this outermost orbit is completely filled. Okay, completely filled means less than 8 electrons are not there, complete 8 electrons are there. Such orbit is called what? That is the fulfilled orbit. Here K shell is the maximum, or we can say that outermost shell. Okay, so here in K shell 2 electrons are there, so we can say that in helium atom this K shell is a, that is the outermost shell is a completely filled. So in both cases, helium and neon, what happened? Their outermost shell are completely filled. Completely filled means what? Their outermost orbit have maximum capacity is complete. That orbit's maximum capacity is complete. Then such orbits are called completely filled orbit. Okay, so here what happened? K shell is the outermost orbit and it has 2 electrons. Its maximum capacity is also 2. So here this outermost orbit is also completely filled. Then this example of neon. Okay, so in example of neon, what happened? Outermost orbit is L orbit. Okay, and that L orbit is also completely filled. Okay, so here in both cases, what happened? Outermost orbit are completely filled. Okay, in both cases, what happened? This outermost orbit is K orbit. It has 2 electrons, so its the maximum capacity is also 2. So it's completely filled. Here outermost orbit is L orbit. It's a maximum capacity of 8 electrons. Here 8 electrons are present. So here in neon gas atomic structure, its outermost shell is also completely filled. Okay, so now if we see the properties of these two gases, then there are, we see that these two gases are generally remain inactive, means they are not make any chemical reaction with other elements. Okay, means if generally what happen, their outermost shells are completely filled. Okay, and if we see their properties, then we will be find that they not react with any other element, whether it is metal or gas. Okay, so generally why these cases happen? Okay, because generally if we see other element, other gases, they generally react with other substances. Okay, but here in this case helium and neon example, if we see, then we will find that they are not react with any other element. So generally the reason behind is that their outermost orbit is completely filled. Okay, what? Their outermost orbits are completely filled. So due to the fill of complete outermost orbit, they not react with any other element. Okay, so look at this reason you have to remember why these two elements are not react with any other element. Okay, so generally what happen, their outermost orbit, here what happen, outermost two electrons are there, so such a orbit is complete doublet. Okay, and 8 electrons are here, so octet. Okay, what happen here in the helium cases, their doublet is complete. Doublet is complete means what? In their outermost orbit only 2 electrons are there, and we know 2 is the maximum capacity of K shell. Okay, means it has only one orbit, and that is the K orbit, and we know maximum capacity of K orbit is 2. So maximum 2 electrons are there in K shell, so it is a completely filled. So such a case is called as doublet case. Which case? Doublet case. Here in case of neon, what happen here, 8 electrons are there in their outermost shell. Okay, if 8 electrons are completely filled, then we can say that octet of this element is complete. Okay, so look at these two elements never react with any other element because of what? Their doublet is complete, their octet is complete. Okay, so if any elements doublet or octet is complete, then that element does not react with any other element. Means what happen, if some element has M shell. Okay, now we take another example of higher gases. Okay, so there are 2, 8 and 18. Now here what happen, in case of, this is the K shell, this is the L shell, and this is last is the M shell. Okay, if some element has M is the outermost shell, outermost shell means what? Last shell from nucleus. Okay, so if that element, if 18 electrons are present in their outermost shell, because in M shell maximum capacity of electron is of 18 electron. Okay, if 18 electrons are present in M shell of some any element, okay, at that time again properties of that element is like these two gases. Means what? As like these two gases, this element will not react with any other element. Means what happens, if these are the outermost shells, if these are the outermost shell and they are completely filled, then such an element does not react with any other element. Okay, that thing we have to clearly understood. What? When this, why this helium, neon, argon, krypton, okay, these are the example of such cases. Okay, if we see periodic table that we will study in 10th standard. Okay, so there are, we see that 18th group of periodic table is for such a gases where their doublet octet are completely filled, and if doublet octet are completely filled, then such a element does not react with any other element. Okay, so these things we have to clearly understood. Okay, so if doublet or octet is not completely filled, means here only one electron is there, or here only 7 electrons are there. Okay, only 7 electrons are there. Then what happen? These elements will be react with other element to complete this octet or doublet. Okay, so look at that. The main funda of reaction is that what? Every element try to complete is a doublet or octet. Okay, so if they complete doublet or octet, then what happen there? So if they are complete their doublet and octet, then they are become inert. Inert means what? Inreactive. They will not react with any other element. Means they are goes on minimum energy state. Is the simply funda of these reactions. Okay, that is the funda of reaction. If here 8 electrons are there, then now this outermost shell is completely filled. Then this atom does not need of any other element to complete its octet. Then it is fulfilled now. Okay, so it is remain at minimum energy level. Okay, so that is why this helium and neon atoms does not react with any other element, because their doublet, in case of helium this doublet is complete, and in case of neon this octet is complete. If doublet and octet are complete, then that does not need to react with any other element and attain a stable state. Okay, so that is why this helium and neon does not react with any other element. That thing we have to clearly understood. So now we studied the atomic structure of helium and neon. We see in case of helium and neon, if doublet and octet is completely filled, then such an element does not react with any other element. Okay, that one thing we have to clearly understood. Now we study the somewhat case of other element. Look at sodium. Okay, we know in case of sodium. So now we have to see one another example of sodium atom. Okay, in sodium atom we know there are total 11 electrons are there. Okay, and that electrons are arranged in particular shells. Okay, look at this is the first K shell. In K shell there are 2 electrons. In L shell there are 8 electrons, and now 1 electron are present in M shell. Okay, M shell is 1. So we know maximum capacity of K shell is 2, maximum capacity of L shell is 8, and maximum capacity of M shell is 18. Okay, so here if we study helium and neon, in helium case doublet is complete. Okay, and in neon case 8, that is the octet, is complete. Means in helium case there are outermost shell, that outermost shell is fulfilled. In K shell only 2 electrons are there, so its outermost shell is fulfilled. In neon atom 8 electrons are there in outermost shell, that is the L shell, so it is fulfilled. So that is why these gases are inert gases. Inert gases, they are also called as inert gases. They does not react with any other element. That does not react with any other elements. Okay, so here if you see case of sodium, so there are we will find first orbit shell is K shell. In K shell 2 electrons. Okay, then L shell. In L shell 8 electrons. Now we have to see outermost shell, okay, and the electrons which are present in the outermost shell, okay. So in case of valency, this outermost shell and this outermost electrons are important. We have to see outermost shell of element and outermost electrons are in that particular atom, okay. So that things we have to see. So look at here, K shell, L shell and M shell. So here M is the outermost shell, okay. So look at, in that M shell only one electron is there, okay. How much electrons in there? One electrons. But we know maximum capacity of M shell is how much? That is the 18, okay. So here 18 electrons are the maximum capacity of this shell, M shell. So this M orbit is not completely filled, okay, is not completely filled because only one electron is there, okay. So that is why this element, okay, has not properties like these two gases, okay. When they are become inert, when the element does not react with any other element, when their doublet or octet is complete. But here in case one extra electrons is present in outermost orbit and outermost orbit is not completely filled, okay. If we see any other element such a carbon element, okay, look at nucleus. This is the K shell, electron 2, 1, 2, 3, 4. Look at, K shell has 2 electrons and L shell is the outermost shell here. In the outermost shell we have to see that here 4 electrons, okay, and we know L shell has a maximum capacity of 8 electrons. So 4 electrons still less to complete this octet, okay. So if we see another one example, okay, we see example of magnesium where 12 electrons are there. Look at nucleus, K shell, L shell, okay. Sodium 11. This is the magnesium. First shell is K shell, it having 2 electrons. Then L shell, which having 8 electrons, okay. And now 10, still 2 electrons are remain. Now that 2 electrons are present in the outermost shell, this shell, okay. So if we see K shell, M shell, L shell, here L shell, K shell, L shell, M shell, sorry, K shell, L shell, M shell. So M is the outermost shell in case of magnesium atom, okay. So we know in magnesium atom 12 electrons are there, in that 2 electrons are present in the outermost shell, where only 2 electrons are present in M shell, but M shell has a maximum capacity of 18 electrons. So this orbit is not completely filled again, okay. So here if we see that element which does not have completely filled outermost shell, okay, does not have completely filled outermost shell, they are react with other element, okay. And the element which having complete filled outermost shell which does not react with any other element. So main concept of reaction is what? Only that where outermost shell is complete or not, okay. According to that we can decide somewhat element is react or not, okay. So here helium and neon are the does not react with any other element because their outermost shells are completely filled. But here sodium, carbon, magnesium, in this case oxygen, other elements, they are also not have completely filled outermost shell. That is why they are react with any other element, and by react with any other element they complete their doublet or octet. Okay, then they will get in a minimum energy state. Okay, so here for today you have to remember only one thing. What? For the concept of a valency we have to study, or we have to well known, that is the outermost energies, outermost shell, and the electrons are present in the outermost shell. That we have to consider only it for the calculation of valency. Okay, so this outermost shell and electron in the outermost shell are important in term of valency. Okay, another one thing we have to remember, if doublet or octet of any element is complete, then that element does not react with any other element. That also we have to clearly understood. And any other elements except these 3 4, helium, neon, argon, krypton. Okay, okay, so except these 3 4 element, other all element react with other element, because their outermost shell is not completely filled. They not have completely doublet or octet. That is why they are react with other element, and that is why compounds are formed. Okay, if all elements are in this form, then we don't have different types of compounds. Okay, we have different types of compound because such a structure of atom of element. Okay, because their outermost shells are not completely filled. Okay, how to calculate valency of an element, that we will see in tomorrow's lecture. But up to now we have to remember very clearly all that things. Okay, so remaining part we will see in tomorrow's lecture. Thank you.